All right, so today we're going to be talking about real numbers. Before we get started, I want to go through the answers to the warm-ups. You should have already given an attempt at these on your own. So what I would do is I would create a right triangle. Now, if some of you made a square, that's perfectly fine. Okay, if you made a square off of it, found the area using your pinwheel, that's perfectly fine. Okay, so first we find the sides, so 3, because we count the spaces, and 2 here. Okay, so we set up the Pythagorean Theorem, 2 squared plus 3 squared equals c squared because we're trying to find our hypotenuse. And if you went through to solve this, you should have gotten the square root of 13, which ends up being approximately 3.6. If you have questions, please make sure you're asking. All right, warm-up number 2, you were deciding on these 3 lengths made a right triangle or not. So we use our Pythagorean theorem to set that up. Okay, so 7 squared plus 24 squared equals 25 squared. Okay, and I put 25 out here by itself, okay, because that goes in our C spot because it's the biggest number out of these 3 numbers here. And if you solve this, you'd find out that they are equal to one another. So this would be, yes, they are right triangles. All right, in number 3, okay, I would first plot the points first. Okay, so 4, 5, and then I go over to 5, 10. Okay, and I always make a right triangle, okay, whenever possible, because we're in our Pythagorean theorem unit. Okay, now my right triangle isn't going to be perfect. Okay, and we count our spaces just like we did in warm-up number 1. Okay, and then we set up our Pythagorean theorem. We're trying to find that distance, this hypotenuse here. Okay, we set that up. 1 squared plus 5 squared equals c squared. And you'd find out that that would be the square root of 26, which ends up being approximately 5.1. Okay, I know it ends up being 5.099, but if we round, it ends up being 5.1. Again, if you have questions on these, please raise your hand. All right, you need to get out your vocab sheet, so please pause the video and take a minute. Get that out. There's more vocab sheets over by my desk. Okay, our first vocab word is rational number. We're going to be talking about rational versus irrational numbers, and a rational number is any number that can be written as a simple fraction. So for example, like 3/4, okay, that would be a rational number, okay, or we could say 1/2. Okay, also we could say 8, okay, because 8 can also be written as 8/1. Okay, so really any whole number or any fraction most of the time is a rational number. Okay, we could even say the square root of 16 because we know the square root of 16 ends up being 4. Okay, so make sure you have some of these examples written down. Okay, also you could have an example of a negative number, okay, because those are also rational. So take a minute, write these down, okay, and we'll go through some more examples in a minute. Okay, so here are a few more if you have some more room on your vocab sheet. So rational numbers include fractions, regular counting numbers, negative numbers, terminating decimals, and repeating decimals. And I'll go more into detail on what it means to be a terminating decimal and a repeating decimal in just a minute. Okay, again, some more examples here. We have a -5, 2/3, 1/2, square root of 16. Now, an irrational number, that is any real number that cannot be expressed as a ratio of integers. So what it means is that it probably isn't going to end up being a fraction. Okay, it can't really be expressed as a fraction, and most of the time, I like to call them ugly numbers. So, like if we have pi ends up being 3.14, and it goes on and on and on with no repeating pattern. Okay, so that would be an irrational number. So if you want to put pi down as one of your examples for an irrational. Okay, also, for example, the square root of 10 If you were to plug that into your calculator right now, you'd get 3.16227766. There is no exact pattern going on. So any number that has kind of an ugly decimal, okay, those are irrational numbers. Okay, so I like to call them ugly. So if you want to write down ugly, okay, so again, an irrational number, any number whose decimal part goes on forever and ever without repeating. Okay, so ugly, ugly, ugly. A few more examples, pi, some crazy random decimal I just made up, and the square root of 10. Okay, square root of 10, again, plug it into your calculator, super ugly. Now I'm going to take a minute and talk about terminating decimals and repeating decimals, and I said these are rational numbers. Okay, so terminating decimal, what that means is that the decimal point stops. Okay, so notice 0.5 or 0.25. Those decimals, if you put them in, they stop in your calculator like 1/2, 1/4. Okay, those are all rational numbers. Okay, so terminating means like stopping something. Okay, so think about it. Decimal point stops. 8.75 stops. So those are rational numbers. Repeating decimals, those are those nice pretty decimals that have a really pretty pattern. Okay, 1/3, 0.333333, 0.676767. Okay, has a nice distinct pattern going on. So anytime you see that nice repeating decimal, we call those rationals. Those will be rational numbers. Okay, so now we're going to talk about natural numbers, whole numbers, integers. We already talked about rational and irrational, okay, but we're going to take a minute and talk about the others. Okay, so real numbers, this is your next vocab word. Real numbers are literally every number you can come up with. Okay, a set of real numbers consists of both rational and irrational. So rational and irrational numbers are they kind of take over all of the numbers. Okay, they're either a rational number or an irrational. If we put all them together, we call them real numbers. Okay, natural numbers. Natural numbers are all of the positive counting numbers, excluding 0. Okay, so please make sure you write down all these examples here so you have them to look back on later. Okay, so all of the positive counting numbers. Now, notice it says excluding 0. That's key because our next vocab word is whole numbers. And whole numbers are all the positive counting numbers like 1, 2, 3, 4, 5, 6, 7, 8, all those, but it includes 0 now. Okay, so natural did not include 0 and whole numbers include 0. Integers, okay, notice that we're kind of adding to it every time. Okay, integers are those positive and negative whole numbers. So now we included the negative numbers when we're talking about integers. Okay, also these include 0. Okay, we're just going to keep building. Okay, so I want you to take a minute and pause the video, and you're going to circle all of the rational numbers. Please make sure you check with a group member so you have them the same. Okay, so circle all of the rational numbers and then check with somebody. Now we're finishing up with a pear deck. There are a few examples I want you to go through. You're going to tell me whether they're rational or irrational. And then the very last slide, okay, we have a set of numbers and your job is to put them in order from least to greatest. Okay, so kind of a key for this is to type them into your calculator first to find the decimals for them all, and then it's easier to put them in order. So kind of think about a number line. Okay, so like if I type in 1/2 into my calculator, I'll get 0.5. Okay, so I'd kind of want to look at that instead. Okay, and if I type in 1/4, okay, I'd plug that in and I'd get 0.25. Okay, so you're going to put all these in order. Plug in pi. Okay, you have a pi button on your calculator, and you type in the square root of 17 and find that decimal. Okay, so put these in order from least to greatest and make sure that I check it before you move on. Okay, and then next, you have a rational and the irrational worksheet, part of your packet, your homework packet. Okay, all of your homework is due on Friday, test day. Okay, so make sure that you have all that done by Friday. This is your last homework assignment because your project is not due until next week. Okay, and we'll have a work day on Monday for that. So you can start your rational, irrational worksheet when you are done with the Pear Deck.